Well, in this section we're going to discuss other types of equations. We have previously discussed linear equations, rational equations. We've discussed complex numbers as well, and quadratic equations. So in this section we'll be talking about equations that are polynomial equations. We'll talk about radical equations, equations that have radicals, and even equations that have exponents that are not integers. So rational exponents, it's like a fractional exponent. But first, let's do one quick review, because this is something that you should have memorized, the quadratic formula. Well, the quadratic formula says, given you have a quadratic equation that looks like this, where you have a 0 on one side, and a, b, and c are the coefficients in this order. In other words, a is the coefficient of the x squared term, and so on. When you are given this, and you want to know that there are two values of x that will make this a true statement, you plug it into the quadratic formula. X is equal to negative b plus or minus, under the radical is b squared minus 4ac, all over 2a. So again, we're just reviewing this because this is something you should have memorized. Well, the next type of equation we're going to talk about, a polynomial equation. Basically, that just means that you've got an equation that's written as a polynomial equals a polynomial. For example, these two are both polynomial equations. Here's a polynomial equation. This well, I'll discuss the degree of this in a minute, but we just have a constant on one side, but this, by the strict definition, is a polynomial. And the second one is 3x cubed plus 2x squared equals 4x to the fourth plus 5. Those are polynomial equal polynomial, so polynomial equations. Here's a term we need to know. What are the degrees of the above polynomial equations? The degree is the largest exponent of the variable x. In this case, the variable's x. So this would be what? You don't see an exponent, but what is the exponent? The implied exponent of that x is 1. So it would be a 1 for that equation. And over here, we get a 3 here, a 2 here, a 4 here. So it looks like it's going to be a 4. Degree 4. And degree, oops, and degree 1 for this one. Now, this is the nice form. This is an example of a polynomial that's in general form. We love this form. We have 0 on one side, and the polynomial on the other has the exponents in descending order. 5, 3, 1. If you mix either of these up, if you switch these two, it's no longer in general form. So we need to have descending powers, descending exponents. All right, and we'll usually write, if the answer is a polynomial, you should always write it in this general form, descending exponents, and have 0 on one side. All right, the last portion for this video is, how do you solve a polynomial equation? Well, here's basically the recipe, and I'm going to do this is a pretty simple example, very simple polynomial on the left and another simple one on the right. We're going to first, step number 1, rewrite it in general form, which as a reminder means get 0 on one side and then put the exponents in descending order. So I'm going to keep the 4x to the fourth. I'm going to do minus 64 x squared equals 0. So to get 0 on one side, I just subtracted this from both sides of the equation. Now, factor the other side that's not the 0 side. So we're going to factor this, which basically means we're going to pull out the greatest common factor. At least for starters, I think that's all we can do. We'll see. Okay, 4 goes into both of these numbers. And then we would take the lower degree, the lower exponent, x squared. So the greatest common factor between these two would be 4x squared. And then, what do I put inside the parentheses? Well, what do I multiply 4x squared by to get this? Another x squared. 4x squared times x squared. Remember, you add the exponents, so you get 4x to the 4th. Minus, and how many times does 4 go into 64? 32, 16. And I think that's it. Well, we're not done factoring, but we pulled out the greatest common factor. We could use the distributive property and go from this to this. All right, one more thing. We got the difference of two perfect squares here. So we'd have 4x squared. Let's see, that'd be x plus 4, x minus 4. And now we use the zero factor property. If I wanted to, I could put parentheses around that. Set that equal to 0, set that equal to 0, set that equal to 0. And what are the values of x that would make this a 0? Well, there's only one. It would just be a 0. So I'm going to say x equals a 0. This one gives us x equals a negative 4. This one gives us x equals 4. So these are the three solutions. And I'll let you go check the solution by plugging them back in. Well, maybe I'll check the first one since it's trivial. When x is 0, you get 4 times 0 to the 4th. 0 equals 0. That one's very easy. Now, before we leave, I'm going to explain why it's necessary that you follow this recipe. You might be tempted to take both of these sides and notice, well, what do they have in common? What could I divide both sides by to make this look much easier than it is? I could divide both sides by 4, and I could divide both sides by x squared. So if I take 4x to the 4th, equaling 64x squared, and divide both sides by 4x squared. Let's see what happens. Let's see, the 4's cancel. What is x to the 4th over x squared? You subtract these exponents, 4 minus 2, and you'd get an x squared equals 64 divided by 4 is 16. And to solve this, we simply use the square root property. X is equal to plus or minus radical 16, which means x is equal to plus or minus 4. That's incorrect. This is the correct solution. Now, you may want to think about it for a minute. Why did I get, and let me put this, let me write wrong. What did I do wrong in this section? Well, we didn't know it, but x equals 0 is one of the solutions. When I divided by x squared, I divided by 0, not knowing it. And that error made us lose one of the solutions. We got the negative 4 and the positive 4, but we missed out on the 0. So I'm going to put an x through this. We should always follow this recipe. Get 0 on one side, everything else on the other, and then factor and use the zero factor property.